Good evening, everybody. So today we're going to go ahead and go over arithmetic and geometric series. And the first thing we have to talk about is something called summation notation. It looks awful, but it's not that bad. And you can see an example of what it is down here. Okay, so this symbol in math it's a Greek letter called sigma. And it just represents the addition. You're adding up things, okay? So what you're going to do is you're going to add up some function, and I'm going to call it of I. And I is going to start at whatever value you want it to. So this is the starting location. In this case, I'm putting I, and it's going to go up to some ending location n. Okay, and then you're going to be done. And I know that didn't make any sense at all, but let's get into it, and hopefully this understands. Hopefully you can understand this. Okay, so when we're doing this example right here, okay, what we're going to do is we're going to evaluate this function in terms of I. And what we're going to do is we're going to start at I is equal to 1, and we're going to plug in 1, and we're going to add it to plug in 2. And then you're going to add it to plug in 3, and then you add it to plug in 4, and then we're going to stop because that is where you stop. Okay, so this lower portion represents where you start, and this upper location represents where you end. Okay, so let's go ahead and let's start this then. Okay, so the first thing I'm going to do is I'm going to plug in whatever this bottom value is, which in this case is 1. So I get 3 times 1 plus 2, and then I'm going to add it. So that was when you plugged in the 1. And then you go to the next term, or the next number. And the next number, which is 1 more than 1, is 2. So you plug it in there, and you have 3 times 2 plus 2. So that's the second one. And then you keep going, like I said, until you get up to the very top one, which is 4. So it's going to be 3 times 3 plus 2 plus 3 times 4 plus 2. And then there I am. I'm at the end, so I stop. And then I just evaluate this. So this will be 3 plus 2 gives you 5, plus 6 plus 2 gives you 8, plus 9 plus 2 gives you 11, plus 12 plus 2 gives you 14. And when you add up everything, you get 13, 24, 48. Okay, so this thing turns out to be equal to 48. It's just a way to write out really long addition problems, but write it out really nicely. Okay. Now, the other thing you should notice here, which is pretty important, is look at these numbers. When you plugged in 1, you got 5. When you plugged in 2, you got 8. When you plugged in 3, you got 11. When you plugged in 4, you got 14. So let's look at those numbers. 5, 8, 11, 14. Oh my goodness, well, that's an arithmetic sequence, right? What is it doing? It's going up by 3 every time along the way. Okay, so this right here in this form, the 3, that turns out to be our common difference D in this form. Okay, I'm going to skip these definitions real quick, and I'm going to go down. Let's do another one. Let's go ahead and evaluate this. Okay, so once again, this is where we start, and this is where we finish. So you start, you plug in 3, so you're going to have 3 squared plus 4 squared plus 5 squared, and then I'm done because I finished with 5, and there's a 5 there. Okay, so this is 9 plus 16 plus 25, which gives you 25 plus 25, which gives you 50. Oops, sorry. Too zoomed in. Okay. So that's how you deal with sigma notation. Okay, so let's go ahead now and let's talk about what an arithmetic series is. I don't even really want to read this definition and this definition because it's like more complicated than what it needs to be. But arithmetic series is simply when you add up the terms of an arithmetic sequence. So say, for example, you had 2, 4, 6, 8, and so on, which is an arithmetic sequence because it goes up by the same number 2 every time. This is a sequence, and if you did this, it turns into a series. Okay, so sequence is just the numbers. Series is when you add up the numbers. Okay, geometric, so if you had something like 1, 2, 4, 8, 16, 32, and so on, so that's a geometric sequence. If you add them up, 1 plus 2 plus 4 plus 8 plus 16 plus 32, then that's going to be a series. Okay, so sequence is when you have a list of numbers or things. A series is when you're adding up those things. Okay, now we have some formulas that you need to know. Okay, so the first formula is the sum of the arithmetic series is given as this. So this represents the sum of the first n numbers. Okay, that's what S of n stands for. N stands for the number of terms added. A1 is the first term, and AN is going to be the last term. Okay, now I pretty much only use this formula. I only have this one memorized. There is this one, and this comes in handy. You'll see that it actually works out really nice down here. But there is an alternative formula. So this is one of the formulas, and here is the other. So this as well is the sum of the first n things. Once again, this is the number of things that's being added. Once again, this is the first term. Now the difference here is it doesn't give you A of n, it gives you n minus 1 times d. And here it tells you what the common difference is. Okay, so that's what it tells you. Okay, so find the sum of the first 15 terms of the sequence 2, 4, 6, 8, 10, and so on. Now this actually doesn't give you what the 8 or the 15th term is. So this one isn't necessarily a good equation to use. I'm going to use this equation. So the sum of the first 15 is equal to n over 2. So that's going to be 15 over 2 times 2 times A1. A1 is the first term in the sequence, which in this case is 2. Plus n is 15 minus 1 times d. And you guys can see the common difference here is 2. So times 2. And then I just have to simplify it, and that's it. So don't write this as 7 halves. Most of the time, this 2 will end up canceling what goes in here, or it goes up there. It doesn't cancel the 15 or reduce evenly. So I'm just going to simplify. 4 plus 14 times 2, which is equal to 15 all over 2. Okay, so this is 28 plus 4 gives me 32. And 32 is 32 over 1. So the 2 goes into 32 16 times. So this gives me 240. Okay, 15 times 16 is 240. You can verify that on your calculator if you want. Okay, for you guys who are really into math and you want to know how I did that in my head, I did that in my head because I have 15 times 15 memorized, which I know is 225. But I didn't have 15 15s. I had 16 15s. Let me restate that. I didn't have 15 15s. I had 16 15s. So I had one more 15 than I did down here. So if I added 15 to this, I get 240. Okay, that's how I did that in my head. Okay, next page. Okay, so find the sum of the first 20 terms of the sequence, negative 30, negative 26, negative 22. Here, if you notice, the common difference is 4. Okay, once again, if you don't see that, then you just take any term in the sequence. So I'm going to get negative 22, and I subtract it from the prior one, 26, so I get 4. So D is equal to 4. Okay, so to find the sum of the first 20 terms, I have A of 20 is equal to... so the formula is right here. I'm going to go ahead and use this one. N over 2 times 2a plus n minus 1 times d. So n all over 2 times 2a1 plus n minus 1 times d. Okay, so in the first case, n is 20. So I have 20 all over 2 times 2 times a1. a1 is negative 30 plus 20 minus 1 times the common difference, which is 4. And then I just have to reduce it. Now here I will go ahead and take 20 divided by 2 because that's 10 and that goes in there evenly. And I'll have negative 60 plus 19 times 4, which is equal to 10 times negative 60. Now, I could do 19 times 4. Another way I could do it, though, is going up here. And this is 80 minus 4, which is plus 76. Okay? If you just multiply those out, you get the same thing. Okay, so this is 10 times 16, which gives you 160. Okay, so that was an arithmetic. If you see that it's an arithmetic sequence, those are the formulas you're going to use. So now I'm going to get into geometric, and there's only one formula for a finite geometric. Finite means you're adding up only a certain amount of terms. Okay, there is an infinite geometric series, which we'll get to in a second. Okay, so find the sum of the first 5 terms. That means n is equal to 5. Of the series 1, 3, 9, 27, that means your r is equal to 3. If you don't see that, take any term in the sequence, divide it by the prior one, and you get 3. Okay, so using this formula, I have the sum of the first 5 terms is equal to a1. a1 is 1 times 1 minus the common ratio, which we said is 3, to the 5th power, all over 1 minus 3. So this is 1 minus. So 3 to the 5th is 243. I've just been doing math a really long time, so I know that. You can do it on your graphing calculator, figure that out. Okay, and this is all over negative 2. So negative 242 all over negative 2. Negative divided by negative is a positive. So this turns out to be 121. Okay, so if you added up the first 5 terms of this sequence, you get 121. Okay, find the sum of the first 5 terms of this geometric series. So same thing, the sum of the first 5 is equal to a1. a1 is 128 times 1 minus the common ratio. Now, what in the world is the common ratio? Okay, once again, take any term in there, divided by the one that comes prior. So that turns out to be 1/2. So the common ratio is 1/2. So 1/2 to the power of 5 over 1 minus 1/2. So this is 128 times 1 minus 1 all over 32 all over 1/2. Okay. 1 to the 5th power is 1. 2 to the 5th power. 2, 4, 8, 16, 32. 2 to the 5th is 32, which is where I came up with that. And then 1 minus 1/2 gives you 1/2. Okay, so I know I need to subtract these from each other. So least common denominator between 1 and 32 is 32. So I'm going to change 1 into 32 over 32. Because 32 divided by 32 is 1. So I have 32 over 2 minus 1 over 32 gives me 31 all over 32 all over 1/2. I flip and I multiply. Sorry, I have to go down here. So I have 31 all over 32 times 2 over 1. Those cancel to 16. My answer is 31 all over 16. Oops, sorry. Can't see it. There you go. Okay, so that is for a finite geometric series. Now, what happens if it's an infinite geometric series? Okay, if it's an infinite geometric series and the common ratio is less than 1, then there's this really nice formula that you need to know. So sum of the infinite series is equal to A1 all over 1 minus R. That's all. Okay, so find the sum of the infinite geometric series, 9, 3, 1, 1/3. So first I'm going to do is I'm going to find the common ratio. I'm going to pick the easy one to do. So 1/3 divided by 1 gives you 1/3. And so the sum of the infinite geometric series is equal to A1. And by the way, this number, in order to use this formula, this number must be less than 1. And it's stated right there. Okay, it has to be less than 1. Okay, so the sum of the infinite geometric series is equal to A1. A1 is 9. All over 1 minus the common ratio. So this is 9 all over 2/3, which turns out to be 27/2. Flipping and multiplying the 2/3. Let me actually do that out. So I have 9 over 1 times 3 all over 2 gives you 27/2. Okay, challenge question time. And you are going to have a question that's kind of a challenge question on your quiz today. Okay, so the sum of the 9 consecutive integers is 9. What is the least of these integers? Well, think about that. If you took the first 9 numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, that's clearly going to be greater than 9, right? You have 9, you have adding all these things on. So I need to back it off a little bit, okay? Which means I'm going to shift it, those 9 consecutive numbers, I'm going to shift into the negatives. So I don't know, let's pick -3 to start off with, okay? So if I go -3 plus -2 plus -1 plus 0 plus 1 plus 2 plus 3, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, that's a 5. Because those are consecutive integers. Now let's add this up and see what we get. Well, if you notice, -3 and 3, those cancel each other out. -2 and 2 cancel each other out. -1 and 1 cancel each other out. 0 is already canceled out. So you're left with 4 times 5, which gives you 9, which is actually what I was looking for. Okay, the sum is 9. So what's the least of these integers? It's -3. Okay? Just to let you know, there is a field of mathematics that is solely focused on series, adding up things. I know that sounds ridiculous, but it's very true. Okay, so that's all I have for today. So hopefully that you guys understood what was going on. If you don't, please feel free to reach out to me, and I will see you next time. Thanks, everybody. Take care.